Roots and radicals. Let's practice little bit of exponents again. Let's review them. 3 square is 9. Negative 3 square is also 9. 3 cubed is 27. Negative 3 cubed is negative 3 times negative 3 times negative 3. It is negative 27. 2 to the power of 4 will give us 16. Negative 2 to the power of 4 will give us positive 16. 2 to the 5 will still give us 32. And negative 2 to the 5 will give us negative 32. So, odd exponents, negative base will give us negative answers. Even exponents, negative base still gives us positive answer. Opposite operation to raising the number to a power is taking root of that number. In general, the nth root of a positive number a is that number r for which nth power is a. So, nth root of a is r, meaning that r to the power of n is a. Now, square root and cubic root are specific examples. The square root of a positive number a is that number r for which when squared becomes a. So, square root of a is r, meaning that r square is a. The cubic root of a positive number a is that number r when cubed becomes a. Cubic root of a equals r cubed equals a. We call the sign looking like this a radical sign. When there is no number, we assume there is 2 there. We call it square root. But if it is cubic root, fourth root, in general, if it is nth root, we write something like this, nth root of a. The principal nth root of a positive number a is positive. The principal nth root of a negative number a is negative if n is odd. If n is even, the result is complex numbers, also known as imaginary numbers, which we don't cover in this course. Find the principal roots of some of these numbers. So, square root of 36 will be a number multiply itself to give us 36. That will be 6. Cubic root of 64 then will be 4, because 4 times 4 times 4 will give us 64. Fourth root of 81 then will be basically 3, because 3 multiply itself 4 times to give us 81. And similarly, fifth root of 243 will also be 3. Some of these we can do it quickly. Some of them we might need calculator to do it for us. If you were to use calculator, all of your calculators should have something looking like this key, nth root of a. So we will write something like this, 5, that key, nth root of a, 243, press equal sign, it should give us 3. Property then, the square root of a product of positive numbers is the product of their square roots, meaning that square root of a times b is same as square root of a times square root of b. Same property can be applied if a and b are being divided. Square root of a divided by b is same as square root of a divided by square root of b. Again, a and b both have to be positive here. Note that if it is adding a plus b, I cannot separate it to be square root of a plus square root of b. It doesn't work that way. Similarly, if this was a negative here, I cannot say it is square root of a minus square root of b. It does not work that way. Okay. One more thing to note down is nth root of a can be written like this or a to the power of 1 over n. They both meaning same thing. Let's see some examples. Square root of 0.49. Some of us can punch in calculator and get it, or some of us can realize 7 square is 49. So this should be then 0.7. Fifth root of negative 32 then is a number which multiply itself 5 times to give us negative 32, and that will be negative 2. Seventh root of negative 83 to the power of 7. Here it's kind of doing something and undoing. So 7th root and 7th power cancels out, giving us negative 83. This one is reminding us of that property again. If there are two numbers being added or subtracted inside the square root, we cannot separate them. So I cannot say this is square root of 5 square, subtract square root of 4 square. I cannot even cancel the square and square roots. What we can do is, we can say 5 square will simplify to 25, 4 square will simplify to 16, giving us square root of 25 minus 16, which will then furthermore simplify to square root of 9 So the result for this question problem will be 3. Square root of 9, simplifying to 3. Now, these ones, we cannot do it manually like the other ones we did. We need a calculator to do it for us. So if you were to do this in calculator, you will press square root, bracket, because you need to specify that this has to go in bracket. Otherwise, your calculator will only take square root of the first number, get the answer, and then divide it by the other number, then add the other number, which is not correct. So if you were to do it in calculator, either add those numbers first and then take square root, or use brackets around it. So the result we should get is 4.14995, and rounding rule says 1/8 if I were to write more decimals. Rounding rule says because it is taking adding and then taking square root at the end, we should look at number of significant digits. Lowest in the question. This has 6, this has 5. So final answer should have 5 significant digit, which will be 4.1499. That's already 5. The next 5 will round it up. So it should be like this. This will be correct way to round it. Okay. And for the last one now, similar numbers, the difference is now it is separated. So if you were to separate them, so your calculator then, you'll do first number square root of 15.9876 plus square root of 1.2345. The result we get is 5.109530, and rounding rule again, look at lowest number of significant digit in the question, which will be 5, or actually not lowest because we are adding at the end. So in this case, we should look at number of decimal places. So this has 4 decimal place, this has 4 decimal place. So our answer should be 4 decimal place. So 5.1095, because next digit is 3, 5 is not going to change. If you were to round this according to significant digit, answer would have been same, but for the wrong reasons. Actually, because we are adding at the end, we should look at number of decimal places, lowest in the question. But both has 4, so it will be 4. Now, if you compare these two answers, the numbers are exactly same, but one is square root underneath altogether, one is separated. The answers are not same. Technically proving this property, you cannot separate them. Okay, it's plus or minus in between. We cannot separate them. We do not end up with same result.